Okay, so in our third example, there is a small caselet that has been given to us, which says that Fun Club in Dubai promotes adventure activities for children in UAE. The club has a budgeted up to $8,000 per week for local advertising. So the money allocated for advertising each week is $8,000. The money is to be allocated among four promotional media. So the company has already selected four media for advertisement. First one is TV spots. Second one is newspaper advertisement. And then there are two different types of radio advertisements. Okay, so TV spots become our first medium. Newspaper ad becomes our second medium. And two types of radio advertisements, this becomes our third and fourth type of mediums that has been used for advertisements. Fun Club goal is to reach the largest possible high potential audience through the various media. So out of these four mediums which has been selected by this company, they want to reach maximum audience. So now we can easily get that it is a case of in fact maximization. Fun Club goal is to reach the largest possible high potential audience through the various media. The following table presents the number of potential families that can be reached by making use of an advertisement in each of the four media. It also provides the cost per advertisement placed and the maximum number of ads that can be placed per week. Okay, so in this given table, on the left hand side we have a column that mentions all the four mediums that has been selected, and while selecting these mediums the maximum number of audience that can be reached. So if we select TV spot, we can reach a maximum of 5,000 audience each week. If we give our advertisement in the newspaper, we can reach 8,500 people each week. And radio spot 1, if we give our advertisements there, we can reach 2,400 mediums each week. And similarly for radio spot 2, we can reach 2,800 audience per week. So this is the analysis that has been done by this company. And on the third column, we have the cost that has been incurred for each of the mediums. So if we have TV spot, then the cost of each ad is equal to $800. If we use daily newspaper, then it is $925. For radio spot 1, for one advertisement, company has to pay $290. And for radio spot 2, the company has to incur $380 for each advertisements. But under any given circumstances, the total amount each week should be less than or equal to $8,000. It looks like to be a constraint for us because under any given circumstances, we cannot exceed this amount. Okay, now in the last column we have maximum ads per week. Okay, so this column states that we cannot have more than 12 TV spots each week. We cannot place more than 5 advertisements in our daily newspaper. Radio spot 1 cannot have more than 25 advertisements each week. And radio spot 2 cannot have more than 20 advertisements each week. So this looks like our 4 different constraints. Okay, we have to look into that. Now, Fun Club's contractual agreements require that at least 5 radio spots be placed each week. Okay, so this company has to select 5 radio spots each week. It should be 5 or more because the word says at least. To ensure a broad scope promotional campaign, management also insists that no more than $1,800 be spent on radio advertisement each week. So this company cannot expend more than $1,800 for radio advertisements. So these two lines also depicts the constraint. We cannot give we should have minimum of 5 or more advertisements in both of these radio channels, and under any given circumstances we cannot expend more than $1,800 on radio advertisement each week. How many ads of each type we place to maximize the total number of people reached? So now, as stated earlier, this is a case of audience maximization. Okay, so we need to solve this problem with the help of Excel sheet. Let us open Excel sheet, and this is our example number 3. So example 3, first we will identify decision variables. So we identified that there are 4 different decision variables. We name it x1, x2, x3 and x4 respectively. The first one is TV spot. The second one is daily newspaper advertisements. So daily newspaper advertisement. Then we have a radio advertisement 1. This is the first type of radio advertisement, and we have radio advertisement of type 2. So as discussed in class, let us place these decision variables as shown on the screen. So we have placed all our decision variables here. So better we place the value decision variables here. That's good. We will leave this row blank as already discussed, and this is a case of audience maximization. So I will write here how many audience can be reached by using these mediums. So we can reach 5,000 audience if we use the first medium, 8,500 if we use second medium, 2,400 if we use third medium, and 2,800 and 2,800 if we use the third medium. So that is our step number 1. Okay, and let us start working on step number 2. We have to identify the optimization function here, and our optimization function is that we should use or we should reach maximum audience. So this becomes a case of audience maximization. We'll not do anything as of now here. Let us first identify the set of constraints we have. So constraints, and defining constraint is our step number 3. So we could easily identify that we cannot expend more than $8,000 per week. So that becomes our constraint number 1, and the total amount is here 800, 925, 290 and 380. The total amount, okay, the sum of this amount which is used by these mediums should always be less than or equal to $8,000 each week. Okay, so let us place these values and name it as constraint C1. This amount should be 800. Second one is 925, 925. Third one is 290, 290, and the last one is 380. Yes. So this amount should be less than or equal to 8,000. So this becomes our first constraint. Let us identify if we have some other constraints in the case. Yes, we have. We cannot give more than 12 advertisement of TV. So it means x1 becomes 1, rest all becomes 0. So this becomes 1, rest all becomes 0 because I'm talking of first type of medium. This should be less than or equal to 12. Similarly, we identify the third constraint, which is we cannot give more than 5 advertisement of daily newspaper. So this is talking of constraint number 2, of medium number 2, sorry. So first one becomes 0, second one becomes 1, third one 0, fourth one 0. This value should be less than or equal to 5. Constraint number 4, we'll talk about medium number 3. We cannot give more than 25 advertisement of radio spot 1. So it is talking about radio spot 1, which is x3. Well, we'll put here 1. This is 0, less than or equal to 25. I think the value is 25 here. Yes, and the fourth one is 20. So we'll identify the fifth constraint, which is talking of radio advertisement type 2. So that is x4. So this value should be less than or equal to 20. Fair enough. We have identified all the constraints. Fun club's contractual agreements require that at least 5 radio spots be placed each week. So we should have 5 radio spots, at least 5 radio spots that has to be placed each week. Fair enough. So this becomes our constraint. We're talking of radio spot. So x1 talks about TV spot, x2 talks about daily newspaper, x3 talks about radio advertisement 1, x4 talks about radio advertisement 2. They should be more than or equal to, and at least 5. So here the value goes 5. Let's see if we have some other constraint. And we cannot expend more than 1800 for radio advertisement because this says so. Okay. So 290 is the amount we spent for radio 1 and 380 for radio spot 2. So okay, so nothing is here, nothing is here. This is 290 because we are talking in terms of money now, and 380. This should be always less than or equal to 1800. Okay, so our Excel sheet has been done. What we'll do now is we'll use the function sum product select all the constraint, comma, the value of x1, x2 and x3 and x4 that needs to be identified, and fix the value of x1 and x2 and x3 and x4. Press enter and then drag it down. Okay, so first step for our calculation has been done. Let us move to the second one. We need to define the optimization. So we'll again use sum product. First we'll identify the how many audience can be reached. Okay, fix it, comma, the amount that has to be calculated, and fix it, close the bracket. Okay, so this step is done. Press on audience maximization sum product function, go to data, press data, go on the extreme right hand side, select solver, all set. Don't change anything here because K11 is already, we have defined that we want to set audience maximization. We want to use the maximum function here, so do not change anything here. Changing variables, yes, we need to identify the value of x1, x2, x3 and x4. Done. We have to set these 7 constraints now. So you press the button add. This value should be less than or equal to 8000, which is stored here. Second value should be less than or equal to 12. press button add. Third value should be less than or equal to 5, add. Fourth value should be less than or equal to 25, add. Fifth value should be less than or equal to 20, add. Sixth value should be more than or equal to. Okay, by default here it is less than or equal to. Press this drop down, select more than or equal to, go to constraint, select 5, add, and seventh value should be less than or equal to 1800. Press OK. All 7 constraints 1, 2, 3, 4, 5, 6, 7. All 7 constraints are set. Then we will select simplex LP method. All set. Press button solve. We get our answer, and once we get all the values, we will show the analysis here. Okay, so TV spot, number of ads. Now we cannot have 1.96 ads, so we will say we need 2 advertisement here, which is as good as 2. Daily newspaper, we can give 5 advertisements, and radio spot 1 is good to give 6 advertisements, because 6.2 is as good as 6, and radio spot 2, as per the solver, we should not give any advertisements here. So how many advertisements we should give? 13. 5 plus 6 11 plus 2 13, and when we do so, we can reach to 67,240,000 audience. Okay, we should discard the value of 0.3 here. I hope you have understood it. Thank you very much.